Hi, I'm Chintan Parek, an applications engineer from the RF Power Group, and today we're going to be talking on the LP8755, which is a multi-phase buck regulator supporting load currents up to 15 amps. First, let's look at the block diagram for the LP8755. Here on the right hand side, we have buck 0 through buck 5, which is the 6 buck regulators. And on the left hand side, we have the control interface, which is an I2C, interrupt, sleep, and a reset functionality. Optional I2C for dynamic voltage scaling is also present. Next, we're going to look at the efficiency graph for the wide range of load currents the LP8755 provides. As you can see here, the phase 0 is in low power PFM mode. Then the phase 0 is in PFM. As we increase the load further, the phase 0 goes into PWM mode. Phase 1 gets activated, phase 2, phase 3, phase 4, and then phase 5. Conversely, as we are going lower in load current, each of these phases will be shedded. So phase 5 goes off, phase 4, 3, 2, 1, and the phase 0 being PWM mode transitions to PFM, and then finally to low power PFM mode. Also, to show to the user that we have a Gui interface provided on the web to be downloaded to control the LP8755. Next, let's look at the LP8755 solution size. Here to show the solution size of the LP8755, we have an evaluation board with the LP8755 at the center and the 3 inductors on the top and the 3 inductors on the bottom for the 6 buck regulators. As you can see, these inductors and their capacitors are small in size, giving an overall small solution size. To demo the phase adding and phase shedding capability of the LP8755, I have a power supply, an electronic load, and an oscilloscope which is looking at the switching node of the buck inductors. As I increase the load current, the phase 0 is in low power PFM mode. As I increase the load current further, phase 0 goes into PFM. Increasing the load current further, it goes into PWM mode. Now increasing the load current further, phase 1 gets activated, phase 2 get activated, phase 3, phase 4, and then phase 5. Conversely, as we are reducing load current, each of these phases will be shedded. So phase 5, phase 4, phase 3, phase 2, phase 1, and then phase 0 goes into PFM, and then finally into low power PFM mode. For the next part of the demo, which is a load transient demo, we're going to reconfigure our bench, and we'll be back shortly with that. For the second part of our demo, which shows the fast load transient capabilities of the LP8755, we have reconfigured a bench with a signal generator and an oscilloscope which shows the load current going from 1 amp to 8 amps, and also the output waveform, which is in the AC coupled waveform. To note, the LP8755 has a differential voltage sensing capability to compensate for the IR drops, and also whenever the output voltage drops by 20 millivolts, all of the 6 phases will be activated. So we saw a couple of demos on the LP8755. First, the wide load range and the high efficiency it maintains over that range. The second being the phase adding and shedding. Third, the solution size. And the fourth, the fast load transients. For more information, please visit ti.com/LP8755. Thank you for watching.